Assalamualaikum warahmatullahi wabarakatuh. I would like to say thank you for coming to this video. Let me introduce myself. My name is Alana. I'm a lecturer in Mathematics Education Study Program at Maritime Raja Ali Haji University. I'm currently studying for a doctoral program in the Statistics and Data Science at IPB University. My supervisors commission are Dr. Anam Kurnia, Professor Dr. Aihamim Gema, and Professor Dr. Muhammad Mu'aid. This research was funded by the Doctoral Dissertation Acceleration Research Camp managed by LPUM Maritime Raja Ali Haji University, 2023. I'm eternally grateful for funding this research. This research is under the research team of the Mathematics Education Study Program at Maritime Raja Ali Haji University in the field of educational evaluation and policy. It discusses educational and teaching output and examines various challenges and obstacles, and carries out analysis to produce solutions and innovations. This research aims to increase the visibility of the impact of mathematics education on society through several dissemination and promotion. This research is done to achieve the research roadmap target for the Mathematics Education Study Program at Maritime Raja Ali Haji University in 2020 to 2025. In this opportunity, I would like to present an article that resulted from this research entitled Modeling the Mathematical Literacy Ability of PISA Participants in Indonesia Using the Multilevel Explanatory Item Response Model. I presented the result of this research at International Conference on Mathematics and Learning Research on September 30, 2020 at Muhammadiyah Surakarta University. Now, this article has status accepted and will be published in the AIP conference proceeding index by scopes. Firstly, we will begin with the introduction. Measurement in educational research require a collection of items as an instrument to measure student ability. Data on student answer to each item are called item response data. Analysis of item response data based on its purpose has two approaches: the measurement approach and the explanatory approach. Analysis of item response data with a measurement approach using the item response theory or IRT model. However, the IRT model has limitations for analyzing item response data with an explanatory approach. Therefore, the analysis of item response data with an explanatory approach is formulated from the perspective of generalized linear mixed model and nonlinear mixed model, and we call the explanatory item response model. The basic principle of IRT in the hierarchical generalized linear model perspective is repeated measurement of participants. Each participant answers the same set of items, so that the answer of item to each participant form a cluster. Observations in a cluster are usually correlated because each participant answers to a set of items depend on the abilities of each participant. So, the IRT model in the multi-level perspective is formulated as two-level model. In this research, PISA participants are the sample unit in IRT. The item response data is hierarchical if PISA participants are collected using multi-stage sample. Predictor of grade and school origin of PISA participants are external factors used to explain difference in achievement level of mathematical ability among PISA participants in Indonesia. This research aimed to analyze the performance of IRT-2PL modeling in a generalized multi-level perspective and to explain the characteristics of item and the influence of external factors on the mathematical literacy ability of PISA participants in Indonesia. The data were secondary data. The data for this study are PISA data in Indonesia in 2018. Used 9 mathematics domain items and total sample in this research was 1,302 participants. The participants from 381 schools and the participants in grade 7 to 12. External factors used as explanatory predictors are participants' background, grade, and school origin. The 2PL IRT model is written as equation 1. And IRT 2PL in the generalized linear mixed model perspective is expanded by including the random component factor structure in random term. The grade predictor in the model is assumed to have fixed effect, while the school origin predictor is random effect. We can see in equation 2. Based on the research objective, the researchers carried out 4 types of model. 1. IRT 2PL model. 2. 2PL model involving fixed grade predictor. 3. IRT 2PL model involving random school predictor. And the last IRT 2PL model involving random and fixed predictor. We call Multilevel Explanatory Item Response Model, or MEIR. Item response data from 1,302 participants on 9 mathematics domains item is as follows. And then, this data is converted into a long format structure. The long format data was processed using the PL Mix package in the R program. Next are the result and discussion. We present the result and discussion in 4 sections. There are item parameter analysis of PISA participants' mathematical literacy ability, the base model, and the last, the effect of external factor on PISA participants in Indonesia. The effect of difficulty parameter from 4 models show that 8 of the 9 items in the domain of mathematics are above the average mathematical ability of the PISA participants. Only item number 1, which is categorized as easy. And then, the graph of discriminant parameter from 4 models show that 7 out of 8 mathematics domain items effectively differentiated the mathematical literacy skill of PISA participants with a value of discriminant parameter more than 1. But item number 4 is quite effective in differentiating the abilities of PISA participants. And only item number 6 can differentiate the mathematical literacy skill of PISA participants. Next result about parameter analysis of PISA participants' mathematical literacy ability. Data used in this research have 182 response patterns. This research shows that adding the random effect of school origin to IRT-2PL model provide more information. The more apparent differences in mathematical literacy abilities between students will make it easier to determine the order of the mathematical literacy ability levels of PISA participants. Then the base model. The selection of the base model was taken with the smallest AIC value. Models with smaller AIC value are considered better for explaining the fit between the model and the data. The results showed that the MEIRM had the smallest AIC value compared to the other three models. So we can conclude that MEIRM is the best model. Last section, we talk about the effect of external factor on PISA participants in Indonesia. The analysis of the MIRT-2PL model with the grade predictor state that participants could explain about 40.3% of the total diversity and another 59.7% was explained by school origin. It proved that the origin of the PISA participants could affect his mathematical literacy ability. School diversity is a challenge in the education system in Indonesia. The different characteristics of each school come from the condition of human resources, location, accreditation, and the average socioeconomic status of participants. The diversity of this characteristic is known as the diversity of school results. The effect of grade predictor in the MIRT-2PL model. The result of the study states that the higher the grade achievement of the PISA participants, the greater an individual's capacity to formulate, use, and interpret mathematics in various contexts, and the chance that the participants would answer the items correctly are also greater. Finally, we can make conclusion from this research. The best model for analyzing the mathematical literacy skill of PISA participants is the IRT-PL model involving predictor of random school origin and fixed grade. Item parameter analysis states that the item in the domain of mathematics were categorized as complex and had good discriminating power. This model produced 1,214 levels of mathematical literacy ability of PISA participants. Grade and school origin predictor have a significant effect on the achievement of the mathematical literacy ability of the Indonesian PISA population. Based on the result of this research, we have some suggestions for our government as an effort to realize an increase in the level of mathematical literacy skill of PISA participants in Indonesia. We hope that the government will realize a fair and equitable increase in school resources throughout the archipelago. We also hope the government can increase the educational attainment of 15 years old children at the senior high school level. This is the bibliography that we use in writing this article. These pictures are documentation during the implementation of ICO-MER activities. This letter of acceptance to AIP conference procedure. Thank you for your great attention. May all those we have shared be beneficial for all of us.